Hello everyone. Today let us discuss some questions related to assertions and reasons. We know these are the questions we found recently in some of the latest question papers. Okay? But you should go through the directions very carefully. The directions are as follows. In the following questions, a statement of assertion A is followed by a statement of reason R. Select the correct option as. That means there are two statements, first statement and the second statement. When you have to choose option A, listen carefully. If both the assertion and reason are true and the reason is the correct explanation of the assertion, means both statements are correct and the second statement is the correct explanation of the first statement, then you should select the option A. And next, if both assertion and reason are true, but reason is not the correct explanation of the assertion, then you have to go for option B. So when you have to choose option B, both statements are correct. That is, assertion and reason both are true, but reason is not the correct explanation of the assertion. Then after that, option C. If assertion is true but reason is false, that means first statement is true but second statement is false. And the last option D, when you have to choose it is when both assertion and reason are false, then you have to choose option D. Okay. Now let's start with our questions. Question number 1. Assertion. Net electric field inside a conductor is 0. Reason. Total positive charge equals to total negative charge in a charged conductor. If you observe this, net electric field inside a conductor is 0. Okay, it is 0. Okay, so in this case, assertion is true. Now let us see the reason. Total positive charge equals to total negative charge in a charged conductor. This is not true. They said it is a charged conductor. Charged conductor means it can be a positive charge and a negative charge. It can be a positive or it can be a negative. Okay, so in this case, total positive charge equals to total negative charge. That is wrong. That means assertion is true but reason is false. So therefore, the answer is C. Okay, and after that, the next question. Assertion. Question number 2. If a dielectric is placed in external field, then field inside dielectric will be less than applied field. Yes, it's true. When a dielectric is placed inside an external field because of polarization, another electric field is developed inside the dielectric. Now, dielectric will get some electric field inside it, but that electric field will be less than the applied field. That is true. And after that reason, electric field will induce dipole moment opposite to the field direction. No, it is wrong. External field induces an electric field in the dielectric in the opposite direction, which sets up a dipole moment in the same direction of external field. What I am trying to tell you is, there is a electric field developed inside the dielectric, but the electric field inside the dielectric is in opposite direction to that of the external electric field, but the dipole moment will be in the same direction as the external electric field. Okay, so now here, now if you see this, second statement is wrong. Therefore, the option is C. Now coming to the third question, question number 3. A wire carrying, if you can see the third question, a wire carrying an electric current has no electric field around it. So wire, whenever a wire is carrying electric field, there is no electric field around it. Then after that, rate of flow of electrons in one direction is equal to the rate of flow of protons in the opposite direction. Now, first if you see, the first statement is correct. When a wire is carrying an electric current, the net electric field around it is 0. Why it is 0? Because there is no means accumulation of charge. As many electrons enter one end of the wire and they go out of the wire from the other end. Therefore, there is no net charge on the wire and there is no electric field around it. Assertion is true, but if you see, the reason is false. Electrons and protons, they are flowing in the opposite direction. No, that is false. So this is the reason is false. Rate of flow of electrons in one direction is equal to the rate of flow of protons in the opposite direction. That is wrong. So the answer is C. Now coming to the fourth question. Assertion. Assertion is the resistance of an ideal voltmeter should be infinite. Yes, true. A voltmeter resistance should be always very high. That's true. That should be ideal, means it should be infinite. Let us see the reason. The lower resistance of a voltmeter gives a reading lower than the actual potential difference across the terminals. Now look at this one carefully. So lower resistance of the voltmeter gives a reading lower than that of the actual potential difference across the terminals. Why we are using a voltmeter? We use the voltmeter to measure the potential difference across 2 points, across 2 terminals. But if voltmeter has lower resistance, then what happens? Current flows through the voltmeter, then the PD across the original one across which we want to note the reading, that will be lower than the actual reading. So this is also true. So that's why we should keep the voltmeter's resistance as high as possible. Ideally it is infinite. Therefore here both the assertion and reason are true, and the reason is the correct explanation of the assertion. Therefore the answer is A. Now let us go to the fifth question. Assertion. If current is flowing through a machine of iron, eddy currents are produced in it. Okay, here we know eddy currents are produced in bulk materials whenever there is a changing magnetic field. We know the definition of eddy currents. Whenever bulk pieces are subjected to changing magnetic field, whenever bulk pieces are subjected to changing magnetic field, eddy currents are produced in that. Okay, so the assertion statement is correct. Now coming to this one, reason. Change in magnetic flux through an area causes eddy currents. That's true. Yes, whenever there is a change in magnetic flux through an area, then eddy currents are produced. Therefore, both assertion and reason are true, and also that is reason is the correct explanation of this assertion. So the answer is A. So you can check once again, if both assertion and reason are true, you can see if both assertion and reason are true, and the reason is the correct explanation of the assertion. So in this case, option A we have to take. Okay, so now coming to the next one. So the next one is sixth question. If objective and eyepiece of a microscope are interchanged, then it can work as a telescope. Now here if you see, microscope is different, telescope is different. Here they are saying objective and eyepiece of a microscope are interchanged, then it can work as a telescope. No, it cannot. A microscope cannot work as a telescope. No, it is impossible. A microscope cannot work as a telescope by interchanging its 2 lenses. Generally, we have 2 lenses in a microscope. These 2 lenses have short focal length. Therefore, the difference Fe minus Fo is small. We know that. But in a telescope, we know objective has much larger focal length than the eyepiece. Now, in this case, assertion is false. Now, let's see the reason. The objective lens of my telescope has a small focal length. No, that is also false. Objective has a much larger focal length than the eyepiece in the case of a telescope. So, in this case, assertion is wrong and reason is also wrong. Therefore, the answer is D. Now, coming to the 7th one. Assertion. the pattern and position of fringes always remain same even after the introduction of transparent medium in a path of one of the slits. So what they are trying to tell us here is, we all know Young's double slit experiment. So there are two coherent sources, two slits are there. Now what they are saying here is, you introduce a transparent medium in a path of one of the slits, not both the slits. In the path of one of the slits, you introduce another transparent medium. In that case, they are saying here, the pattern and position of the fringes always remain same. So even if you introduce a transparent medium in the path of one of the coherent sources, that is in between the medium, then what happens? What they are saying, the pattern and position of the fringes will remain the same. No, it cannot be. It cannot be, because after introducing a transparent plate in the path of one of the coherent sources, in the path of this one of the slits, then what happens? The path difference will be mu minus 1 into t between the two waves. It will produce a path difference of mu minus 1 into t. Mu minus 1 into t, that will produce a path difference of mu minus 1 into t between the two waves. Therefore, there will be changes in the position of the central fringe. So, assertion is wrong. And then coming to the reason, the central fringe is bright or dark depends upon the initial phase difference between the two coherent sources. This is also wrong. In Young's double slit experiment, in the interference pattern, always in the center we have a bright fringe. So central bright fringe is bright or dark depends upon the initial phase difference between the two coherent sources. No, this is also wrong. Therefore the answer is D, that is both are wrong. So both are wrong. Now coming to the next one, eighth one, assertion. Photoelectric effect demonstrates the wave nature of light. Photoelectric effect, we know whenever light comes and falls on a metal surface, electrons are coming out of the metal surface. So it explains us that light contains packets of energy. These they call as quanta, or they also call them as photons. But it does not explain us the wave nature of light. Therefore, this statement is wrong. Then coming to the reason, the number of photoelectrons is proportional to the frequency of light. No, that is also wrong. Number of photoelectrons depends on the intensity, but it does not depend upon the frequency of the light. Frequency, what it will do, whenever the frequency is greater than the minimum frequency called as threshold frequency, then only photoelectric effect is possible. So the number of electrons is directly proportional to the intensity of the light. Therefore, both the statements are wrong. So the answer is D here again. Now coming to the next problem. Problem number 9, the question number 9. Assertion. Total energy of an electron in a hydrogen atom is negative. Now let us understand it. And the statement, reason what they have given, electron is bounded to the nucleus. Yes, electron is always bounded to the nucleus because of electrostatic forces of attraction. We know that hydrogen atom is atomic number 1. One proton and one electron are there. Therefore, and even the electron is very close to the nucleus. There is a force of attraction between them. That is electrostatic force between them. That is a force of attraction. Therefore, electron is bound to the nucleus. That's true. And therefore, the total energy of the electron, it comes in negative value. That's true. So, both are correct. Assertion and reason both are correct. And also, reason is the correct explanation of the assertion. Therefore, the answer is A. Now, coming to the last question. 10th question. Assertion. At a fixed temperature, silicon will have a minimum conductivity when it has a smaller acceptor doping. So we all know intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors are pure form. At room temperature, they are almost like insulators. But when you increase the temperature, slowly the pure semiconductor will start conducting. But when you add impurities to a pure semiconductor, its conductivity increases. When you add pentavalent impurity, it becomes an N-type semiconductor. When you add trivalent impurity, it becomes a P-type semiconductor. When you add pentavalent, it is N-type. When you add trivalent, it becomes a P-type semiconductor. Now, what they are trying to tell is, at a fixed temperature, that means at one particular temperature, silicon, that is a pure form, will have a minimum conductivity when it has a smaller acceptor doping. Doping means adding impurities to the pure semiconductor. Yes, when you add impurities to a pure semiconductor, its conductivity increases. So conductivity of an intrinsic semiconductor, it is increasing when you add impurities, whether acceptor or donor. Then reason. The conductivity of an intrinsic semiconductor is slightly higher than that of a lightly doped p-type. No, pure semiconductor means intrinsic semiconductor. It has a conductivity always less than that of a doped semiconductor. That means impure semiconductor. Intrinsic semiconductor's conductivity is always less than that of a extrinsic semiconductor. Therefore, in this case, reason is wrong. Therefore, assertion is true, but reason is wrong. Therefore, we say here the answer is C. Okay. With this, I have discussed 10 only here, because more than 10 it will take quite a long time. Okay. All the best for your exams. God bless you all and grant you all great success. I wish you all a brightest future. God bless you all.